food. All right, so last class we finished up, we were talking about stacks, okay? And I need to like constantly be quizzing myself. When it came to stacks and we thought of the array, where did we push onto the array? We pushed
At the end of it?
at the end, and we popped
At the end.
at the end, following the whole LIFO, last in, first out. Linked list, where did we push?
At the end. Or
Or
yeah, the head basically.
yeah, the front, yeah. And we also popped from the front. So when it was stacks, they were the same. I don't know how you can remember stacks and same, but if you found a way, just to keep this straight, because what we're going to do today when we talk about queues is we're going to go into FIFO, which is first in and first out. But there might be test questions on the first test, like if I take an int stack, you know, again, we know the int stack versus the dynamic int stack. That's the names we're using from the Gaddis book. You know, write a function to data data is a fair test question. Part of the problem is keeping straight stacks and queues, LIFO and FIFO, arrays and linked list. You know, if I pick one out, which one is it we're using? Where do we add and take away from? Kenneth is here. Good morning, Kenneth.
Hi.
We were waiting for you, and then I said, "To hell with that. We're moving."
Yeah, I agree.
I'm recording. I can't do that. Okay, so today, that's my little review. I need a review once in a while to keep track of all that. Today, we're going to hit queues. Today, we're going to hit queues, okay? And as a queue goes, it's FIFO. And if you travel to a foreign country, you're going to hear a queue all the time. And an example of a queue would be, it's first one in, first one out. If you go to a foreign country, they say, "Oh, go get in the queue." What are you getting into?
Line at a fast food place.
Line.
Yeah, you're getting into a line, right? You're getting into a line. And, you know, at a grocery store is a good example. So just keep that in mind, because the first one in the line is going to usually be the first one out. So we have that as an idea. All right, so we're going to take a look today again at this whole beginning process of looking at a queue, the dynamic versus the static. Okay, so, you know, again, we're looking at the array versus the linked list. And I'm thinking in a little bit, I might be making notes in here for my array. Let's talk about it first. Okay, so I have an array. Let's see what we got. And I know the first one in is going to be the first one out. All right, so I'm starting to think of the same way we worked with stacks. We're going to have queues, and we're not going to have push and pop. We're going to have some other values or other names that we'll talk about. But if I take a look at an array and, you know, let's say the first person is Bob, and then it's Mary, and then it's Calvin, and then it's Alvin, you know, that kind of thing. And they start to walk, you know, walking through the grocery store, and they come up, and Bob is the first one in the line. Okay. So if it's empty, I got to stick it at the front. And so, you know, Bob shows up and Bob enters the queue. Hey, Bob, how you doing? Good day. Did you find everything you needed? All right, good. Mary enters the queue. Where will we put Mary? Do you want to put her in the front? Do you want to put her behind? So which way do we do this? Where are we going to put Mary? I heard her behind. So Mary would go in the second spot. Okay, remember our options were to put at the end or put here. We didn't like the whole shifting over kind of idea. Okay, so B enters the queue, M enters the queue. So now all of a sudden B is leaving the queue. So we want to delete them from the queue. So if I get ready and delete from the queue, what happens? B is gone, right? See ya, B. Now what do I do?
Move the M to the front.
Move M to the front, okay? Because why?
Because it's first in, first out.
Right. Okay, so let's keep, so you'd like to move Mary to the front. So one of the things we mentioned the other day is we need to be real careful with, what if I have 1,000 records and I pull somebody off the front? Now all of a sudden I have to shift everyone left. Is that something we really want to do?
No, you can just move the head of the list over one.
Okay, so that's an idea. Well, what if I made a very small array? And I'm working with this array. Okay, well, eventually I'd do what? I'd run out of memory. I may have one person in the queue and all of a sudden I have a problem because the next person coming in, I don't have a place to store them. So that's almost like saying, I can only service a maximum of 10 people today, then I'm gonna be tired, I don't wanna do anymore. So maybe shifting is an option. A enters the queue. All right, well, here's what we're gonna do instead. Instead of doing all this and the shifting and possibly running out, what if I got all the way to the end, and I started deleting people and I got to the end and Sally was the last one in the line and all of a sudden Tobias shows up. Where could I put Tobias? Super duper looper. Whoa. Could I put Tobias down here at the very beginning? Could I have it wrap around if I wanted to? The answer is yes.
Yeah.
Yeah. So in order to do this, I'm thinking for my array, I'm going to simply do B gets in the queue, right? And I need to know where that is. M gets in the queue. How do I know where to put the next person if nobody's deleted? Well, I'm going to have to actually keep track of the front and the rear. So if I added an A without deleting anybody, rear is going to go to here. And I'd keep going and I'd keep moving rear. I'd keep moving front till I got to a certain spot. And then where would rear have to go? Well, rear would have to rear its ugly head. Rear would actually move around to the front. So I may be looking at something eventually that looks like this. Here's my front, and that's W. And over here I have Z, Q, and Y, and this is my rear. Okay, so my front could possibly be pointing to this location and my rear would have to be pointing around. So that way I could keep working without doing major shifting, but have a situation that looks like this. Okay, so just quick notes. I'm dealing with an array. When I deal with the array, I enter, what did we say earlier? We were using push and pop, but here I NQ at the end, I DQ from the front. Maybe we could even call this rear because it looks like I'm going to have to keep two variables, front and rear, with locations in the array. So yeah, this is FIFO. First in is the first out. So the last one in is going to be the last one out. So these sort of go opposite. When I enter at the rear. When I leave from the front of the line. So it's kind of like these two comments we have up here, now that we're in queues, we have this for the array. Enter from the rear, delete from the rear. Okay. So if I come down here and I started talking about entering the queue, this is, I'm going to enter and go into 3. I have 6. I'm going to have 3 and 6. I DQ. All I would have left is 6. So again, check this out. Kind of an interesting note to have. An empty queue, the front is -1. The rear is -1. When I add something, front gets that value, rear gets that value. When I added another thing, rear got moved over to here. So I'm trying to keep track of my test data. When I work with an empty queue, if it's empty, the first thing that comes in looks like front and rear are both going to be 0. If it's not empty, as I enter, rear is going to be 1 more than what it was. When I DQ, I'm going to have to DQ from the front. So front's going to have to move over 1. I'm going to be looking at situations where, what if I now did a DQ and got rid of the 6? Where do front and rear point? What's going on with comparing of front and rear? I'd also have to look at, if I'm at the end and I have to move, I'd have to do like maybe a mod or something to get back to the beginning. I don't know that I need mod because I know the beginning is 0. Might be good to have enum items to keep track of all this. So if you were writing NQ and DQ, those are some of the things that you'd have to be thinking about. Okay. All right. What if I now want to work with a linked list? Okay, so I said an array, I said NQ, rear, DQ from the front. So if I was going to now take a look at a linked list, do I need those 2 pointers? What do I need? How do I do it? I'm going to NQ. A, I'm going to NQ. B, I'm going to DQ. I'm going to NQC. So I'm starting to get some basic test data of what's going on. What if I said, oh, now I'm going to be DQing. I'm going to DQ. Anybody want to go to Dairy Queen right now? DQ. Could I DQ again? Uh-oh. One of the things in DQ I'm going to have to check for, is it empty? One of the things I needed on the other side was when I did NQ, was it empty? Because if it was empty, I had to set the front and the rear both to 0. There's a little bit of coding going on here, kind of idea. All right, let's see, NQ. It's empty, so I need a new node. I have a new node, it's A, it points to null. And I'm just going to think right now, I'm going to call this, well, we might as well call it front again. All right. NQ. NQ. So now I create a new node and that points to null. This time it's B. What are we thinking here? So do I enter the queue in the front before the A or enter the queue in the rear after B?
Rear.
You like it in the rear, okay?
Sure.
So at the rear of the linked list. So if I had a somewhat larger linked list, again, I have to draw pictures. So I have A, B, and C, and now I create D, and I want to add D. What am I going to need here? Front is here. It's a pointer to the front. What else do you think I'm gonna need?
Rear.
Yeah, I'm gonna need a rear pointer. That's gonna point to the end. This guy now points to null. So I'm gonna need to do, I think, and this isn't so bad. You know, this certain situation, if I wanna NQ, right, the D, if I wanna enter D to the Q, I need to simply go and say, give me some code here,
Change the point. Change C's pointer to D
okay?
from null.
Tell me what to write.
Rear equals D.
No, because then I'd lose all of this. How
Rear's
about
pointer.
rear's next? Go ahead.
Oh yeah, rear's next equals the D there.
Well, that D is gonna be my new node,
Yeah.
okay? So right now, I just changed this pointer to point down to my new node. So this pointer goes to my new node. What's my next line? Because this guy has to change, right?
Set rear equal to D or point to D
Okay, but we said D is called new node.
or new node. Yeah.
So yeah, that's not so bad. So to add to the end, I need to change this pointer so that it points to this guy, and this pointer so that it points to that guy. What if I'm entering from the front? If I'm entering, so for this guy, I enter front, exit rear, kind of same idea. If I'm entering from the front, I have a new node. Let's just call it that infamous little z, because that'll go before A. I don't know. That would go. So if a new person comes, no wait, we enter from the front. What are we doing in the rear? Don't look at that. We enter to the rear. Got that. I messed up. So this is part of NQ. What would DQ be? That means I want to take A out. What would I have to do? Well, in our world, we're going to say temp pointer gets a value of head. Head gets a value of y'all aren't good at this game. Oh, why am I calling it head when it's front? Excuse me. Maybe I'm not so good at this game either. Front gets the value of front next. And then what? So now this guy has temp pointer going there. This guy now points to there. Destroy temp pointer.
Do you have to destroy the temp pointer?
It's a good habit to get into. That destroys that node and frees up the memory.
All right.
Do we need the temp pointer if we're just interested in getting what the value is? Couldn't we just jump straight ahead to the front is equal to front next?
You can get
After we
away
get the
with
value.
just that, right?
Okay.
Right. But if you don't have a temp pointer, you can't use the destructor to destroy the node. Which for a lot of you still doesn't make sense why we want to free up the memory. There will be something coming up where we have to free it up, dealing with arrays. All right, I apologize for all the scribble on here, but that's me on the whiteboard making notes and carrying on. So what is it I want you to do? Well, go to D2L and download the first offering I give you. You're going to get a program. And let me see if I can find it. If I go to D2L, I have to refresh. And it didn't come up, did it? Da-da. Where are you? Maybe we went too fast. No, there's big O notation. What's the date today? The 11th? 10/20. Why in the heck 10/20? That's kind of late. Okay, so I'm gonna have to make these live available to you right now. Here's the first one, and give me 1 second. Okay, so you're gonna go to D2L. You're gonna see a project that you're gonna put together. Program 18.7. It has intq.h, intq.cpp. Now everything's ready to roll except when you open up intq.cpp, you'll see that NQ and DQ are missing. So what I want you to write without looking in your books is the NQ and the DQ for the array. Now this is the hardest one of the two. As you know, the one for Q's is going to be a lot easier for linked list is going to be a lot easier. So we're going to go with the challenge of doing this one first. If you get it done, then come back and you'll see the dynamic Q, dynamic in Q, same thing. DQ and NQ are missing for you to fill in.
Are these the same files in chapter 19 folder?
Yeah, are we off by a chapter? Chapter 19, yeah, chapter 19. But I don't want you getting your book out and looking at them yet.
No, like are they the same exact files as there's a inq.h and inq.cpp in the chapter 19 folder?
Probably,
Yep.
yeah. Yeah, they're the
Okay.
same. I just put them there for you. We have 11. That sounds like 3 groups. We're okay with that. We're missing 4 folks today. What's up with that?